Okay. So dear students, alumni and colleagues, so welcome to the introductory sessions of the PPE Lustrum. We are glad we can celebrate the 5th anniversary of the PPE program. In the introductory part, 4 people will share some recollections of the previous years and look forward into the future. So I've been Dean of the College for the last 2 years, but before the involvement in the college, with my involvement in the college goes back much longer, I guess almost 10 years. I remember a meeting in the philosophy department 10 years ago where we discussed possibilities of building connections with the other faculties, and there was a consensus that the PPE program was the most sensible option. Soon a plan was worked out to start a new program with the faculties of the social sciences and the School of Business and Economics. René van Woudenberg, now chair of the PPE exam committee, took the lead, and Michel Heidra, now in the advisory board of PPE, wrote a concrete plan. But unfortunately, no permission was given since there was a moratorium on new programs in the Netherlands. So 2 or 3 years were lost this way. This is a pity because we were probably the first PPE program on the European continent, but we were too soon followed by other universities. So apparently PPE was very much in the air. Finally, the newly founded Faculty of Humanities could take the initiative under the deanship of Michel ter Hark to restart the process, and as Dean of Education of the Faculty of Humanities, I was deeply involved. And this was quite an experience. We were lucky to hire Martin van Hees as a new professor, and he did an enormous job in starting the program. It's unbelievable what you have to do to start a program. The administrative work to get a program approved is dreadful. We even had exams for all the first year courses even before a single student was admitted. And finding the location was a challenge. We have explored many options, from building a separate college in town to the Symphony building on the Amsterdam Zuidas, and we finally ended on the 3rd floor on what is now the John Stuart Mill College. At the start of the program, I became a bit less involved. I guess many alumni will remember me from the crash course in logic at the very start of the first year. And I was the head of study for philosophy for the first 3 years of the college, but Martin van Hees and Ben Ferguson did all the work. But I could see the vibe in the program. We started with over 30 students in the first year, and since then, we welcomed 100 students every year. Then 2 years ago, I was asked to take over the position of Dean of the College from Martin van Hees. I agreed and assumed that this would be a relatively easy job. The program went very well and only some residual issues remained to be solved. In particular, the organization of the support staff was important. Many people have done a great job in the organization of the college, but the workload was just unbearable in the first year. I'm very glad that we have more stability now, and Michelle, Maria, and Nike are doing a great job supporting future, present, and former students. At the very moment, I thought everything was getting organized and we could start preparing for the reaccreditation of the program, we were hit by one of the most serious crises in modern history. We heard of the crisis in China, but suddenly the corona pandemic came close. I had planned to give a lecture in Lugano at the beginning of March 2020, flying over Milan, but this was cancelled. And I was really afraid of becoming a global super spreader, taking the virus from Milan and working in a very international environment. But soon there was some worry about students returning from ski trips. Then the board meeting of PPE in March was cancelled, and I knew drastic measures would be announced. Exams were cancelled and teaching had to go online overnight with no one having any experience with any of that. So period 5 of last year was an uncomfortable exploration of what could be done online, but already in period 6, courses and thesis projects could be planned quite naturally. A truly major disappointment was the cancellation of the international exchanges last year. But thanks to the work of all involved, we have worked our way through a very difficult year this year. Teaching online is quite a challenge. Talking to a screen all day is truly exhausting. But listening to a screen 16 hours per day is challenging too. So even with the greatest effort from lecturers, some fatigue set in. And having an online community is not the same as having the events live PPE is famous for, the Calliope event, the extracurricular events, graduation day, and so on. We are confident that all this will be possible again. I was very glad to be able to teach actually this morning for the first time in a long time in the college again. And we are very glad to welcome a new cohort of students next year in what will in all likelihood be normal circumstances. Looking back, I think PPE has become a strong program. The program is well organized, students can choose their own path, but have a quite wide scope of courses. Teaching in the PPE course now, I became ever more convinced of the value of our program. The combination of the three disciplines is a very good way to look at global problems, climate change in my course now. I'm a bit surprised that economic naturalists merely aim at giving policy advice and want to remain as neutral as possible in the normative domain. Also, politics tries to remain as descriptive as possible. But I think the normative cannot be avoided, but careful reflection on norms and values is needed, and this is what philosophy offers. So sensible policy briefs without the integration of the three disciplines I find misguided, and I think we offer the right training for people who will influence the course of society in future years. And at the end of my introduction, I would like to thank an enormous amount of people for realizing the program and leading it through its first 5 years. The board of the university, the board of PPE, the heads of study, the administrative staff in the university and the faculty, the lecturers in the programs, and many others involved. But in particular, I would like to thank the people that tie the program together. The program coordinators, Roland Luttens, Patrick Overeen, Ben Ferguson, Phil Robichaud, Boris Slijper, and very soon Özlem Terzi, are absolutely crucial in the functioning of the program. They oversee the program and smoothen out issues with all the lecturers. And also the junior lecturers, Akshat, Brian, Marina, Stefano, we had Sanne, Diederik, Steve, and Baris, had and have a most crucial role in the college. They tie together the program and the lecturers, are approachable for students, inform the staff about what's going on, and do a great job teaching, and are very well appreciated for their seminars. And we are looking eagerly for the first PhDs that will result from their research in the college. And most of all, we thank our students and alumni for the pioneering year, from the pioneering year with whom we started the program to the new students that will start next year. They are the reason why the program was started in the first place, and they helped us through the first 5 years wonderfully, even in the bizarre times we have encountered. And a very special word of thanks goes to my predecessor, Martin van Hees, without whom PPE would not have been possible at all at the VU. And I very gladly pass on the floor to him.
Thank you. Dear friends, colleagues and students, it is a privilege to be able to say something on this occasion. I was asked to give some personal reflections, and there was a suggestion for 3 themes. What does PPE mean to me? What are some personal highlights of your time as a dean, and development of the college over time? Now, I took my assignment quite literally, and I'm going to discuss each of those 3 topics briefly. Say a little bit about it. So first, what does PPE mean to me? And actually, this goes back to when I was a student. I was studying, first of all, I started studying political science, and I was captured by philosophy and political philosophy, and I was surprised that philosophy was just a subordinate part of the political science studies. I was also surprised that economics played a minor role. I then studied philosophy as well, but I always felt within the philosophy discipline also to feel somewhat limited by the fact that there are these other perspectives that we didn't incorporate. I thought when you look at the study of human life, and that's in the end PPE all about, then you would expect that economics, ethics, philosophy more generally, and politics play a role. So for me, it was very natural later on to discover that there are such programs, and it was a very natural step to try to also have PPE programs in the Netherlands. And it's not only about the topic or the substance or the themes of PPE, which I think are really natural to combine the 3 disciplines, but also core methods. So if you do, say, ethics or philosophy, then you can profit enormously from the contributions from economists, from the tools, from the toolbox of the economists. I'm confident that political science can learn from philosophers, that economists can learn from political scientists, etc., etc. So there are all these very productive crossovers. As, by the way, we shall see also this afternoon with Professor Thompson's lecture. So for me, the discipline is a very natural one. It's not, it doesn't feel like a new one, although it's a relatively new one. Then personal highlights. Well, I think it's fair to say that really the personal highlight for me as a former dean was, together with the people that even mentioned, designing the program. That was really a beautiful, challenging, sometimes tiring experience, but it was so rewarding to really design a program basically from scratch with the group of people. That was enormously interesting and rewarding. And also, I think when we composed the program, we thought about the program, I mean, we made a careful international comparison. So we studied other programs, and we discovered that there's this distinction between first generation and second generation programs in PPE. And we said it should really be a second generation program. That means that various elements of the program really tightly fit together. And we tried to do so without losing the diversity of the different perspectives, because there is diversity, even though the three naturally cling together and belong together. I think it is natural. It is also natural to encounter diversity and differences. Sometimes these differences are really merely superficial. And one of the joys of developing, being part of the development of the program, is to discover, you know, the similarities, the differences, and sometimes, as I said, the fact that what appears to be a difference was in the end based on a common understanding. I remember, just to give you one example, I remember talking with Marjan Hofkes in the early years, and she was referring to the study by economists of the theory of the second best. And I didn't know what this theory of the second best stood for. And then we talked a little bit, and then it turned out to be roughly similar to what political philosophers would call non-ideal theory. And then I thought, okay, that would be really fun to, you know, to use some of the ideas developed by the economists in political philosophy. And that's just one of the examples in which there are all these productive and fertile crossovers. It not only pertains to the program, the curriculum itself, but also to the place, the location. And I think in the end, it even referred to the quest. We really had a quest for the right location, and in the end, we opted for the 4th floor of the main building of the VU University. And I think it's a beautiful choice. It's a beautiful fact. It symbolizes the fact that PPE is really in between and among the faculties that are involved. So I really think that, you know, being on that floor and having our own community, our own college among and in between the faculties really is indicative of something that we try to realize with the program. Finally, let me say a little bit about the shaping or the development of the PPE over time. And I would like to do so via the idea of shaping a community, because PPE is not only a program, not only an academic program, it's also about the development of the John Stuart Mill College. But a community is something that you cannot devise on paper, that you cannot formulate behind your desk. And it's really about trying to formulate and trying to find and trying to realize shared values, common goals, realizing a certain culture. And I think the first years, from my experience being involved there, was really trying to find and to formulate and to realize those shared values. And if I now look back, I think the culture, the PPE culture could be described in terms of respect, mutual respect. There's diversity of perspectives, engagement, strong engagement with the world around us, openness, and also fun. I mean, we did great stuff. We had, you know, events together with staff and students, which really were expressive of not only the fact that having this community was something that is worthwhile for academic reasons, but also fun. And in terms of personal development, whether you are a student or a staff member, an important element. So the many activities on campus, the trips, for instance, the summer schools that we organized in India, And there are many, many elements which really helped create this culture. And I think this is an ongoing process. It will not end. But I am really proud to have been part and to have been able to play a role in the creation of this community. So in the end, I think PPE is always about people. And as I said, I'm proud to be part of that community of PPE people. And with that remark, I will now give the word to Akshat Jitendranat, junior lecturer and PhD student in the PPE program.
Thanks, Martin, and thanks, Leven, as well. I had prepared something to say, but it turns out the session is being recorded, so I cannot be as reckless as I had planned to be. But as my students know, I'm not going to pass on the opportunity to speak for 5 minutes uninterrupted, so I'll wing it and see where we land, right? But I want to continue from where Martin left off, right? The community of the PPE. But let me start where it started for me. It was a beautiful day in April, much like today is in Amsterdam. And there's this tradition that Dutch people have, right? For those of y'all who are not Dutch, y'all might know this tradition that whenever it's 15 degrees and there's a little bit of sun, Dutch people choose to take off their clothes and sit in the park, right? That's how one celebrates the sun in the Netherlands. And on a day like this, I did not choose to participate in this Dutch tradition, but traveled from Rotterdam to Amsterdam for an interview for my for this role, as it happens. And I gave my interview, and on the train back, I was thinking about, oh, this, not only is this so much fun, but like I was being very self-critical about how the interview went. Happily for me, by the time I reached back home that day in 2016, I got an email from Martin, who incidentally, and Martin, I'm going to embarrass you completely over here, is part of the reason I moved to the Netherlands, to be able to work with Martin. But I got an email when I got back to Rotterdam that I've indeed got the position. And that was one of the most beautiful days of my life. Sun shining outside, beautiful news in your inbox. And as I've come to realize, the summer before your PhD actually begins is one of the most beautiful summers that you might hope to have. And why was I overjoyed? I was overjoyed in part because of what the PPE education was aspiring to do, right? What the PPE program was aspiring to do. You wanted to provide an undergraduate education that was world-class, that wasn't just about, let's do a little bit of economics, let's do a little bit of political science, let's do a little bit of philosophy. But you had simultaneously a grounding, a really sophisticated grounding in each discipline, but you also had classes where you had to bring these three disciplines together. Teaching in such a program was, of course, enormously exciting. Research, well, I am, like most of us in the PPE community, a little bit of intellectual schizophrenic. So this is just perfect for me if I like all three disciplines and don't have to choose. So that bit's exciting. So for these reasons, to be part of a really great research and teaching program, I was so excited, right? But soon I realized that this is just one of the great communities to be a part of, right? A few of our old students are in the audience who we all went to India with and had a great time in the summer school over there. Who can forget the pub quizzes we did in the first year of PPE, where you would get pizza and drinks and have a quiz in the evening on the 4th floor in the John Stuart Mill College. And of course, we all chose, none of us are sadists, but we all chose to watch the 2016 US election together. And we know how that went. That was the election of Donald Trump. But yeah, we sat up all night seeing the horror unfold before our eyes. And Also, for me personally, PP has just given me great colleagues and friends. And here I want to mention my other colleagues who are now friends, my junior lecturers, Brian, Marina, who is here, Stefano, Sana, Britta, who unfortunately left in between, Diedrich, and now Steve Ottoman and Baris, right? So looking back after 5 years, it's the community that I value the most and the friendships that I've got to cultivate. And the fact that I'm in this community teaching in a program that I'm jealous of and I wish I could be a part of, but also being able to do research in PPE, this is of course a reason to celebrate. Now, I've been looking back, and you might rightly accuse me of doing so with rose-tinted glasses. But if there's ever an occasion to wear rose-tinted glasses, today provides such an occasion, not least because of the beautiful weather outside. But hindsight is, of course, 2020, and I choose to conclude by saying something about what the future may hold for the PPE community, as well as for teaching and research in PPE, right? So we have a situation where teaching and the community has had to move online. This, of course, gives students the wonderful opportunity to take naps between lectures or stare at the ceiling and question every life choice that they've ever made, right? But it's, of course, given us new tools to provide an education. So going forward, how are we to combine what we've learned from teaching in the pandemic to teaching when things open up again? And in terms of the community, how are we to combine some of the great things that doing this online has managed, the opportunities of moving online has managed to open up for us? We have had people from all over the world come and give us lectures virtually, of course. It would be nice to meet again in person. And of course, I hope that happens soon. But I think going forward, the pandemic, and especially now that we're all getting vaccinated slowly, gives us the occasion to think seriously about where we want PPE to go and how we want to learn from 5 years of delivering an education on in person, but also the past 2 years of the pandemic. So I'll stop there, I think, and I'll pass it on to Bea. Yeah.
Thank you, Akshat, and also thank you, Martin and Lieven. Hello, everyone, and also thank you, Michelle, for inviting me here to share my thoughts on 5 years of PPE and also my experience as a student and as president of Calliope this past term. As it seems to be, well, recurrent, PPE to me also means community. The funny thing about the PPE community, though, is that it is very, very diverse in opinions and ideas. And what brings us close are these characteristics that we share, our core, even you could say. And for example, one of these characteristics, I think, is the shared passion towards understanding and shaping the world, of making an impact. So one can easily recognize this PPE person, PPE personality, or even the PPE conversations. And you'll find these like in all PPE students and PPE staff throughout all years and groups. I definitely have been able to witness this first when getting to know my classmates last year when I started PPE, then when meeting the first years this year at the Freshers Weekend, but also then when conversing with some third years or alumni. I think it's a truly unique phenomena, and that makes the PPE community very, very special. Then also to continue with the questions, since same as Martin, I also decided to shape my reflection around these. How the John Stuart Mill College has changed over the past 5 years is probably the question I would know the least of. But I think it is something that is present and that comes through when you talk to some professors, PhDs, alumni, and students from other years. And one of the biggest changes I at least can recognize is that the John Stuart Mill College has become a very lively environment, and especially I think thanks to the many initiatives and events. So from Calliope, PPE Encounters, PPE in Person, to the staff's events and projects. It's one of my favorite things about the college, and it is reflected literally every Wednesday. I can't wait to see, though, what new initiatives arise and how our still young community continues to develop. Also, something else that I think has changed over the years is the relevance and openness regarding students and staff's well-being and mental health. It is one of the few positive things, I think, from the pandemic that has put on the table things as important as mental health and the struggles that arise, especially intensive programs such as PPE, but also LGBTQI+ inclusivity through the addition of a gender-neutral bathroom at the 4th floor. I hope that these changes, that have been taking place these years, continue and lead to an even more conscious and inclusive college and program. Then lastly, a personal highlight of PPE for me would be being on the board of Calliope. Since our study association is deeply interconnected with the program and the community, being part of the board enabled me to be very active in shaping our community, to get to know and work with not only my fellow board members, but also committee members and other enthusiastic, fun, and inspiring students. It also helped me to understand PPE and the college better and to feel closer to it. And to conclude, I wanted to add that one of the biggest highlights for me and most students is just to have been able to meet so many different people and to create bonds, friendships, relationships that will go beyond PPE and hopefully will last entire lifetimes. Yeah, now I give the floor to Renee. Thanks.
Okay, thank you, Bea. Maybe we should wait till 5, or Michelle, or can we just continue?
Just continue.
Just continue. Okay. So welcome. It's my pleasure and honor to introduce the first main speaker of the PPE Lustrum, the first PPE Lustrum, and it's William Thompson, who will be giving the John Stuart Mill lecture. Let me present one slide that I prepared. Okay, I apologize. There is some delay in my slide. So, okay. So it's my pleasure to introduce William Thompson. So William is the Elmer B. Milliman Professor of Economics at the University of Rochester, who did his PhD at Stanford in 1976. And since then, he became one of the most influential economists, especially in economic theory. So this resulted in writing over 100 articles and several books on economic theory. For example, books on bargaining, fair allocation, and claims problems. And what is one of the very special things on William's articles and books is that he does not just present some results, but his work is always embedded in a broader discussion about the methodology, why we use a certain methodology, and how to apply methodology to come to certain results, which also makes that the type of economics that William does fits very well in PPE. So I want to pick up two books specifically. One is in fact forthcoming. It's the book The Axiomatics of Economic Design. It's not yet out, but it will be out soon, I hope. Where, as the title suggests, it's about the axiomatic methods in economics. And I think this was definitely a recommendable book for everyone who is interested in, say, the PPE view on economics, and of course recommended to all economists. And the second book that I want to highlight a bit is the book which is not necessarily about the theory itself, but it is a guide for the young economist, which is a book that, that helps young people, young economists, but I would even say young researchers in general, about how to become a good researcher and specifically how to write your articles, how to present your work. I think this is a very valuable work for many people I know. And in fact, several people in PPE own this book. So I think if you go on the 4th floor through the PPE bookshelves, you will see several copies of this book. So this also brings me from the role of William Thompson as a teacher. So of course, he has a very influential as a researcher, but also he is very influential as a teacher. Of course, directly to his own students, as you see, as I mentioned here, William is a PhD supervisor of more than 50 PhD students, of which some of them, or many of them, again, are very successful professors at important universities, and they educate their students. So directly, William has educated many students, but indirectly, he also has been very influential, for example, by his book, Guide for the Young Economist, but also many other young researchers who were not his PhD student, but who I know also from our meeting at conferences. Many young researchers had contact with William or visited him in Rochester, and they are always very impressed by the attention that William gave to young researchers. So William has a very big influence as a researcher. He's also very influential and motivating for young researchers. And therefore, I'm very happy that William will give this J.S. Mill lecture for a very young generation of the PPE students. So thank you very much, William, for willing to give the talk. And before I give the floor to William, for the audience, so the people in the panel, they can ask questions directly to William. Other participants, you cannot talk directly in the meeting, but you can ask your question in the Q&A. If you use the Q&A button, then Roland or me, we will moderate and we will forward the question to William. So the idea is that after the lecture of William, we have a 45 minutes for discussion. So a lot of time for discussion. But if you have clarifying questions during the talk, then William is very welcome to answer them. Okay, thanks again, William, and please take the floor. I think you're still muted, William.
Should I start, René?
Okay. Oh, now I was muted. Yes, you can start.
Okay, so you'll see my screen and you can hear me.
Yes,
okay.
We hear and see your screen.
Very good, thank you. Well, first of all, thank you very much for the invitation. I'm very honored to give this lecture and very pleased to meet so many young people. And I can feel the enthusiasm of your program. It's a wonderful feeling. So thank you also, René. And René I've known for quite a while, and we have never had an opportunity to write a paper together, but I hope it will happen sometime. So the other thing I'd like to say is that I didn't know the word lustrum before. So even though in French we have the word lustre, which is related and is derivative of lustrum. So I have my old Latin dictionary from high school. It's a 1700-page dictionary, which I love whenever I need to look up a word. And I opened it, and it turns out it opened exactly at the page containing the word lustrum. So I think I was very pleased, and it meant really that I had to give this talk. So thank you. So lustrum, I don't know whether you know all the ramifications of this word, but it had to do with the census in the Roman times that happened every 5 years. And there was it was a time of purification, of sacrifice. And I don't know whether your plan is to sacrifice some chicken at the end of my talk, but I was sad not to be there in person, but if I miss the sacrifice of the chicken, then maybe that's okay. So let me start. I'm going to talk about two things, really. I'm going to talk about the adjudication. Oh, by the way, can you remind me how long I have? Michel?
Yes. So the talk is 1 hour.
Okay, that's what I thought. Okay, so I'm going to talk about two things. I'm going to talk about the adjudication of conflicting claims, but I'm going to use that as a vehicle to talk about the axiomatic method. So my plan is to divide my presentation into two parts. One is about the axiomatic method, and not so much about my own work. And then in the last 15 minutes, maybe, of my presentation, I will talk about some current project that I'm involved in that has to do with claims problem. So let me try to advance to the next. Okay. So the outline of my presentation is this. I will ask, what's a claim problem? Define what that is. I will give some historical example of situations of that type. I will show you some rules to solve claims problem. I will. This is the part of my presentation that's based on this book that René was talking about. I want to show you how to organize the field of axioms. And I say homage to Linnaeus, this Swedish naturalist who proposed a general classification of the natural world. So it's a contribution in that spirit of Linnaeus. And I will show some characterization, and then I will show you some current project of mine. And I will end by discussing where the literature on claims problem is going. So that's my plan. So this is the claims problem. The claims problem is very simple. By the way, I will use very little notation, and except at the end when I talk about my own work, there will be a few mathematical expressions, but otherwise it will be mainly verbal. But still, I need to explain formally what the claims problem is. So what we have in the screen here is a claims problem involving two people. And so it's a two-dimensional space. Agent 1 has a claim that I call C1. Agent 2 has a claim that I call C2. This is a claims vector C. It collects everybody's claim. And then there's a line here, slope -1. And the line of equation T1 plus T2 equals E. E is the amount that you have to divide. And so what we have here is a situation in which you have two people with claim on some resource, but the resource is not sufficient to honor those claims. So think about bankruptcy. A firm goes bankrupt. The liquidation value of this firm is E. Two creditors are coming to get their money back. Obviously, you don't have enough. And the question is how to divide what you have. How to divide when there isn't enough. And so what I'm going to do is look at this budget line. And obviously, we cannot be above the budget line, right? I think it would be dumb to be below the budget line. So we need to pick a point on the budget line. And I think we're going to limit ourselves to this segment from A to B. Why? Because those are non-negative vectors. I don't want to give to someone -5, if somebody comes to get his money back and say, okay, give me $5, that wouldn't work, right? So we should get a non-negative amount and nobody should get more than his claim. And so there will be a non-negative condition here. I should be above the origin. I should be below the claims problem, the claims point, and I should be on the budget line. My budget equality, my budget constraint should be met as equality. So altogether, I'm going to pick a point from the segment A to B, but you could see the whole continuum. Which point should I pick? And so a rule is going to tell me what to do for every problem. So I'm going to give the name S to my generic rule. S of CE is going to be the recommendation made by the rule for the problem CE. And the question is what S should be. So here's my notation. The claimant set is equal to N. The claims problem is a pair CE. So if I have N people, it's a point in N plus one dimensional space. And the summation of the claim is at least as big as E. I will allow for the equality as a limit case. And I will denote by C super N the class of the domain of all claims problem with claimant set N. And then a rule is a mapping that tells me what to do for every problem in this class Cn. So the rule is going to take its values into n-dimensional space. So that's what the rule is. And what is the goal? The goal is to identify the best rules. So now you could ask this. How can I possibly say anything interesting about a point and a line? Because that's really what the problem is, right? Your claims problem is a point and a line. So that's ridiculous, frankly. And in fact, you know, I just published a book on claims problem, and it sounds pretty strange that I should be publishing a book about a point and a line. So let me give you some excuses or reasons. First of all, in the n% case, it's going to be a point on a hyperplane, right? So it's a little bit more general than a point on a line. So here's a 3% problem. Three people here, the claims vector is a point in three-dimensional space. The budget line is going to be replaced by a budget hyperplane. So you can see this plane here. So it's a plane of equation T1 plus T2 plus T3 equal to E, where E is going to be the endowment. I'm going to use this term for the amount to divide the endowment. And this plane passes below the claims vector. What I want again is to pick from that hyperplane a point that is non-negative, is bounded above as a claims vector. So in this case, to be this polygonal region here that goes from alpha to beta, gamma, you know, all those Greek letters. You see this polygonal region here? I need to pick from that region. So another reasons why this class of problem is interesting is actually very important. You know, societies have had to deal with situations of this type, you know, forever. You know, people have borrowed money and been unable to reimburse their creditors for a very long time. So it's a very important problem. There are also other interpretations of the formal model. One of them is taxation. So think of a community, a group of people that have decided to build some project, to undertake some project. The cost is E. And what we're going to do is to assess taxes, right, to cover the cost. So the coordinate of C would be the incomes of the taxpayers. And so the sum of the incomes is sufficient to cover the cost of the project. That's why you can undertake it. And the question is how much each of those taxpayers should contribute to this project. So it's a typical taxation problem, was the most fundamental problem in economics, right? So it is covered by this formal model CE. And you know, instead of basing contribution on an income, you could base it on benefits that people derive from the project, or on some aggregate, you know, of incomes and benefits. But the formal model covers that. There are lots of fascinating historical examples. I will mention some of them, having to do with how to solve claims problem. There are lots of interesting rules. You know, in many domains of economics, we actually have very few rules to talk about. If you think about object allocation problem, if you think about even, you know, our classical, the classical model of economics about textbooks. You know, when you have a group of people, each person has its own endowment and, you know, in n-dimensional commodity space, and you have to redistribute those endowments. There are not so many rules there. But in the context of claims problem, we have tons of rules and tons of interesting rules. And we have lots of positive results. So if you have looked at axiomatic work in some other fields like matching or the classical problem of fair division or object allocation problem, you end up very quickly with negative result or, you know, dictatorship or, you know, and positive result, but that, you know, you can do things, but not in such an appealing way. But for claims problem, we're going to discover that many positive results emerge. And also, even though, you know, claims problem is a point on the line, there's a lot of fun mathematics. And so all branches of mathematics have played a role in the understanding in the literature on claims problem. So finally, there are many ways to enrich this base model. You could say, of course, it's overly simplified, you know, CE. So when I write a model like that, you know, I'm obviously abstracting from many features of the real world, but the model has been enriched, and there is a literature on enrichment of the problem, and I will discuss at the very end actually the direction in which this literature is moving. And for me, you know, because I'm a teacher, this model of adjudication of conflicting claims is I call it a pedagogical paradise. Why? Because it's very simple, and everybody has an opinion about it. Everybody understands what it's about. Everybody has an opinion, and so people you can engage people in the conversation about what to do, about how to solve a bankruptcy problem. And the other thing that you don't need to know any economics. You know, you need to know about demand function, about Hessian, and you don't need to know any of the technical stuff. Anybody understand what a claims problem is? Okay, so here's some of the sort of examples. I'm going to go quickly over that. You know, already Aristotle said what is fair, what is proportional, what is unfair is what values a proportion. So what Aristotle suggested, you should make payments or awards proportional to the claims vector. So everybody gets 50% of his claim, or everybody gets 75% of his claim, depending upon the relationship between the sums of claim and the endowment. In the Talmud, there are some very interesting examples of claims problem. In particular, there's a story that, you know, if you go to a yeshiva, like a traditional school, you learn about that problem called the contested garment problem. It has to do with two people claiming ownership of a garment, of a piece of clothing. And there's one person who says, it belongs to both of us. And the other guy says, no, it's mine. And so the question is how to divide this garment. So if you give a value of the garment, let's say 100, there's one person who claims 50, right? Because he thinks they jointly owns the garment, and the person who thinks that he's the owner is claiming 100. So it's an example of a claims problem. You know, 50 plus 100 is bigger than 100. And the question is, how should you divide the garment, or the value of the garment? And so the Talmud has a recommendation for that, which is not the proportional recommendation. There is another well-known example that has to do with a marriage contract. You know, when a man and a woman get married, a contract is signed, it's called a ketubah, and it's a monetary amount that the woman is supposed to get in case of dissolution of the marriage, which would be either divorce or death of the husband. The man could have several wives. So suppose that you have a man who's has married 3 women, and their contract specifies they should get 100, 200, 300. But his estate, when he dies, is worth only 100. What should you do? So the Talmud makes a particular recommendation for that. The Talmud also makes a recommendation for the case of 200, an estate equal to 200, and for an estate of 300. Those recommendations are not compatible with proportionality. And for many, many centuries, people wondered, you know, where do those numbers come from? And so those are the fascinating examples in old literature. There's some example in Maimonides, you know, 12th century. Maimonides was apparently called the Great Eagle. It's not the nickname I gave to him, you know, that's the way he was called at the time. So he has some numerical example, and implicitly, actually, some of the examples point very explicitly, I think, to a rule that I will define shortly called the constraint equal award rule. I will explain what it is in a minute. And another 12th century scholar, Ibn Ezra, who was called the wise, the great, and the admirable doctor, he also has his own example. And a different rule was based on the recommendation made for this example. And this rule is not any of the rule that underlies the example that I just discussed. And so, so what are those rules? And so what I want to do is to give you some examples of rules and to show you, in fact, the richness of this inventory of rules that one can talk about. So what I'm going to do, if you look at the picture on the left here, I've specified a claims vector, and then I've shown several budget lines. And for each budget line, I've indicated what the rule could pick. So this is the lowest budget line, where the lowest endowment is 0, right? If you have 0 to divide, then everybody gets 0, right? Everybody should get to by non-negativity, you know, you don't have a choice. You have to pick 0, 0. For this high budget line, maybe you have picked this point. For this high budget line, maybe you pick this one. And for this budget line, you pick this one. And this is the highest budget line when it turns out you just have enough to reimburse everyone. And so you have to pick C, you know, by definition of a rule. So what I'm going to do is to connect all those points. And what I do is what I get is a path. I'm going to call this the path of a word of the rule for this claims vector. I'm going to do that for every C. And so what you have on the right here, I've done it for C bar, for C lower bar, and I have a portrait of the rule. And my advice, if you get involved in this problem, think about rules as collections of passive words indexed by claims vector. Think of them as those geometric objects, this collection of geometric objects. That's the best way you're going to solve problem, understand how rules function. And so I'm going to show you some rules now. So the first one is the proportional rule. I'm going to start with what one could argue is the most important rule. The proportional rule, you know, the passive word for C is just a segment to C, right? I want for every budget line, I want to pick an awards vector that's proportional to C. So the portrait of this rule is going to be a bunch of segments in the two-dimensional space. You have two claimants. So this is a constrained equal awards rule. I'm not going to do equal division, right? Because sometimes if I do equal division, somebody could get more than his claim, right? So what I'm going to do is to start with equal division. You know, if the endowment is small, I do equal division, and I do that until the smallest claimant is fully reimbursed. He has to drop out at that point, and I continue with equal division for the others. And there's only two people here, so I don't have a choice. I continue up to the claims vector. So more generally, what you do, if you have n people, you start with equal division until we get the smallest claim. The smallest claimant drops out. Then you continue with equal division for the others until they get the second smallest claim. The second smallest claimant drops out. And you continue with this one until you reach the claims vector. That's the algorithm that gives you the passive award or the constraint equal award rule for a typical claims vector. Now, that is the rule that Maimonides recommended. And as I said, you know, he does that by example, not by graph, or he doesn't give a formula, or he doesn't give, you know, he doesn't use modern mathematical language, but I think he has enough examples that for me, I'm completely convinced that if you were to show him this graph, he would say, of course, that's what I meant. So next, I'm going to talk about the constraint equal losses rule. Oops. The constraint equal losses rule, which is here, it's kind of another implementation of the goal of equal division. Except that this time we're going to look at what people are not getting, the losses they incur. So at any given awards value can be looked at positively. You can look at where focus on what people are getting. You can also look at what they're not getting, right? The losses they incur. And if your goal is equality, why not equate losses? But this time we have to be careful about non-negativity, right? So let's start with endowment equal to the sum of the claims, and everybody gets his claim. If we're missing $1, everybody gets his claim minus 50 cents. If we're missing $3, everybody gets his claim minus $1.50, and so on. So we go down this line of slope 1 until somebody reaches 0. It's going to be the smallest claimant, of course. We don't want to impose any additional cost on this person, so we don't want to continue this way. So instead, he's going to stay at 0. So any additional dollar that's missing is going to be taken in equal parts from the others. So the general algorithm is you start from the top, you impose equal loss on everybody until this common loss equal to the smallest claim. The smallest claimant drops out. You continue with equal losses for the others until the common loss equal to the second smallest claim, and so on and so forth until you get to the origin. And you can recognize a kind of symmetry between those two schemes, right? And that symmetry is going to be expressed formally as an axiom of duality. And this is a different type of path, which is kind of strange, maybe, piecewise in 3 pieces. But it is a path that actually rationalizes all the example in the Talmud that I talked about, the contested government problem and the 3 wise problem. The recommendation made in the Talmud for those examples are rationalized by this kind of path, which I've shown only for the 2% case. And you can see this kind of a hybrid between constraint equal reward and constraint equal losses. What I'm going to do here is, you see this point C over 2? And look at this little box here with origin 0, and the top will be C over 2. What you have in that box is a replica of this path that I had here. So what I'm doing here is apply the constraint equal rewards rule. And then if I look at what's above C over 2, then what this path looks like is what I had on the left here. And indeed, the Talmud rule is kind of a hybrid of those two, consequential rewards and consequential losses. So what you do is this. Let's start with an endowment equal to 0. What I'm going to do is to apply the consequential rewards rule, but I'm going to use the half claims instead of the claims themselves. So I do equal division until we get half of the smallest claim. The smallest claimant drops out for a while. We'll have to come back later because at the end we have to get this claim. So I continue with equal division for the others until they get half of the second smallest claim. And the second smallest claimant drops out at that point for a while, and so on. I continue in this way until everybody has reached his half claim. So I've covered all the endowments running from 0 to the half sum of the claims. For endowments that are greater than that, I start from the top. Then I apply the consequential losses rule, but again using the half claim instead of the claims themselves. So initially, everybody gets this claim. If I'm missing $1, this missing dollar is divided equally between everyone. I impose equal losses on everyone until this common loss incurred by everybody is equal to half of the smallest claim. The smallest claimant drops out, and I continue with equal loss for the others until their common loss is equal to half of the second smallest claim, and so on. So you get two schemes. There's one scheme going up, one scheme going down, and they meet in the middle when the endowment is equal to the half of the claim, and this midpoint here is a proportional point, actually. So that's the Talmud rule. So we have 4 rules already. And actually, this Talmud rule here can be justified in some other ways. So I will discuss later a rule called minimal overlap. I will give the definition at that point. Another rule that is commonly discussed, and I can give you the definition, is very simple, called the random arrival rule. And by sequential priority rule or other type of rule. And then you get a families of rules that have been discussed. Young has identified and characterized a very interesting family that contain a number of the rules that are defined, and there are some other families that have been introduced. So the point I think I've made already is that we have many, many interesting rules. Well, I don't know about the interesting part, many rules, right? And then I'm hoping that by the end of my presentation, you'll be convinced that they're all interesting. Let me say a few things about the random arrival rule. The random arrival rule works as follows. Imagine people coming at random. Actually, let's pick an order of arrival. Let's imagine people come in to get the money back in a particular order. So what I'm going to do is to reimburse people one at a time, fully reimburse them until I run out of money. So when the first person arrives, I check whether I have enough to fully honor his claim. If I can, I do that. If not, he gets everything. If I have more than enough to fully reimburse that person, I turn to the second person in that order, and I check whether I can fully reimburse him. If I can, I do that. If not, he gets what's left, and so on and so forth. So what we have here is a sequential priority rule, right? A sequential priority rule associated with a particular order of arrival. So that's not fair, right? Obviously, if you arrive first, you are much more likely to get your money back. So to make it fair, I'm going to assume that those orders of arrival are chosen randomly with equal probabilities. I'm going to take the average. You know, the set of rewards factors is a convex set. So I take a convex combination of rewards factor, so then I get another rewards factor. So which means I can take an average combination of rules. Each sequential priority rule is a well-defined rule. You know, it satisfies all my basic requirements, non-negativity, claims boundedness, and balance, you know, being on the budget line. And so for each order in which people can arrive, I have a well-defined rule, a sequential priority rule associated with that order. And I can take the average of those rules and I get another rule. And that's a random arrival rule. So those are rules. So let me ask that famous question again. What is to be done? You know, we have many rules here. As I said, you know, if you compare this to other fields of economics, I think the only field that comes close to having as many rules is bargaining theory, a la Nash. So then we have, you know, a nice collection of rules to work with and study and use. But most other fields of economics have really very few rules to work with. So what are we going to do? I mean, which rules should we use? I mean, you can look at the definition, have a sense of what it you know, it's appealing or not, but for me, what should be done is to apply the axiomatic method. And so let me say a few words about the axiomatic method. What is the axiomatic method about? What is its central position? The central position of the axiomatic method is that what makes the rule interesting are the properties that it satisfies. The primary concept are the properties of rule. If you tell me we should be using this or that rule, I'm going to ask you why. And I think the only reason you're going to be able to give me because this rule is efficient, because this rule satisfies that, this strategy proof. So ultimately, the properties of rule are what we care about. That's the central position of the axiomatic method, that the primary concept are the properties of allocation rule. And we call them axiom. So what's an axiom, formally speaking? So an axiom is a mathematical expression of some intuition we have about how a rule could behave or could be required to behave in certain situations. That's my definition of an axiom. Now, what's an axiomatic study? Well, in axiomatic study, you start by formulating some axioms that you think are compelling, and then you try to understand the implication singly and in various combinations. That's what an axiomatic study is about. Now, what's an axiomatic accusation? An axiomatic accusation is a theorem that identifies a particular rule as being the only one to satisfy a particular list of axioms. Or it could be a family of rules that to identify as being the only rule satisfying a particular collection of axioms. Sometimes, you know, if we're too ambitious, we get any possibility result. What's that? Well, it's a list of axioms that are incompatible, that we show are not, cannot be met jointly. And what is the axiomatic program about? The goal of the axiomatic program is to trace out this boundary between those combinations of axioms that are compatible and those combinations of axioms that are not compatible. And our goal is not, actually, I don't see our goal is to choose between the axioms. Our axiom is to offer this menu to whoever is going to use our services. It could be the bankruptcy judge, it could be the administrator of a school choice program, it could be the taxation authority, and we have a conversation with them. And we tell them, well, what do you care about? You know, what's important to you? And we try to express formally what they're going to tell us. You know, they're not going to be able to tell us formally what they care about. It will be our job to translate this discussion into formal action and then to show them the implication of those axioms. You know, what's and they will have to choose. It should be for them to choose. So let me show you some axioms. So here's some axioms that have been important in the study of claims problem. Actually, we have a few more, and we have a few more. So what point am I trying to make in showing you those lists of axioms is that we need to put some order in that field. And people who are not familiar with the axiomatic method, or who have seen maybe glimpses of it, maybe have attended a seminar, you know, they tell us, oh, you have too many axioms, you have too many possibility results in your field, and I'm not going to get involved. So in this book that I'm completing on the axiomatic method, my goal was to put some order in this field, that so that we to organize it somehow. And that's why I call it my Linnean project. So I say it's an homage to Linnaeus, you know, who attempted to organize the entire natural world. And so I'm trying to organize this field of axioms. And so that we can see better how they fit together, instead of having this amorphous mass of concepts. And so, unfortunately, I'm not going to be able to deliver a tree like Linus did, but hopefully there will be some useful, you know, partition and maybe themes that will help us see a little bit better what this subject is about. And so what I did in this book actually I'm proposing two ways of organizing this field, according to format and according to content. What I'm going to do is to use claims problem as illustration of all the definitions that we proposed. So let me start with axiom format. So here's the first distinction that I think is useful. So I like to distinguish between universal axioms and model-specific axiom. So an example would be equal to of equal. Equal to of equal would say if two people have equal claims, they should get the same thing in the context of my model here, right? Two people with equal claims, C1 is equal to C2, X1 is equal to X2. So I'm going to call X, the typical choice made by a rule for a particular problem. So take two people, let's say agent 1 and 2, check whether C1 is equal to C2. If that's true, you want X1 to be equal to X2. Agent 1, the word should be equal to agent 2, the word. So that's universal, that axiom is the expression of universal idea, right? It applies to almost any type of situation. You could check whether two people have the same characteristic. And if they do, they should get the same thing. It could be equal payoffs, it could be equal utility, it could be equal welfare. In my case, it could be equal awards. So claim monotonicity is an example of a model-specific axiom. Claim monotonicity says if somebody's claim goes up, that person should not get less, right? If C1 goes up, then X1 should not go down. Agent 1's award should not go down. Agent 1's award should be at least as big as it was initially. So obviously, I'm talking about claims here. I'm talking about claims problems. That's a model-specific axiom. Another distinction I'd like to make is between a punctual axiom and relational axiom. So a punctual axiom is one that applies to each problem separately. So claims boundedness in the context of my model, claims boundedness is one, right? For each problem separately, I can check whether the award I pick is bounded above the claims vector. And endowment monotonicity says that if the endowment goes up, everyone should get at least as much. If there's more to divide, the claims vector being fixed, everybody should partake in this extra bonus. So that's a relational axiom. I'm comparing two situations that differ in a particular parameter. And I'm expressing my intuition as to how the choice made by a rule should respond to the change in this parameter. That's a relational axiom. It sounds like a trivial distinction. It turns out I've seen many misconceptions about the axiomatic method that come from the failure to distinguish between those two basic categories of axioms. So I like to add it to my inventory of axioms. Another distinction I just think is useful is between a pre-application axiom versus a post-application axiom. So for a pre-application axiom, we don't apply the rule. On the hypothesis side, you don't see the rule. And for post-application axiom, you need to apply the rule to formulate the hypothesis. So endowment monotonicity, which I just explained, is a pre-application axiom. We have two problems that differ only in the endowment. And so that's the hypothesis. The endowment is one is because the endowment is the other. There's no reference to the rule. And so that's a pre-application axiom. And then there's a conclusion, of course, that will involve the rule. And composition down is a post-application axiom. So let me explain what this means. So I'm going to tell you the story to motivate composition down. So imagine that we are on, I'm a bankruptcy judge, and on Monday, those people are coming to me for advice. And so they show me the data of the problem, the claims factor and endowment. And I come up with a recommendation and I tell them, okay, tomorrow come back and I'll give you your checks. And they come back on Tuesday, and it turns out that, we made a mistake, or they made a mistake in calculating how much was to be divided. Instead of E to divide, we have only E prime, which is smaller than E. So we have to redo the division. I'd like to propose two ways of redoing the division, of looking at this new situation, of assessing the situation. One is to say on Tuesday, well, forget what we did on Monday, right? We don't have E to divide, we have E prime. So let's reapply the rule to the problem in which the endowment is E prime. So that's one way of looking at the problem, of the situation. The alternative is this, on Tuesday morning, those two people are coming with certain expectation. On Monday, we told them that they would get certain amount, X1 and X2. They're coming on Tuesday to get those amount, X1 and X2. They're coming to claim X1 and X2. So why not use x1 and x2 as claims on the smaller endowment E primes that we have discovered is what we have to divide on Tuesday. So we're going to apply the rule to the problem in which the claims as what we promised them on Monday, and the endowment is that smaller value that we have discovered is the only amount we have to divide on Tuesday. So there are two very natural, I described two scenarios in which that we can use, to solve this problem. This is the situation in which we find ourselves. And I don't know which is the correct one. I don't know which is better. I don't know which is more justified. So we're going to say that the rule satisfy composition down if it actually makes the same recommendation. We have two equivalent or just as justifiable ways of looking at this situation. And if the rule makes the same recommendation, then we avoid a fight. That composition down. That's obviously a post-application axiom. Right? We need to apply the rule to formulate it. On the rule will apply on the rule will appear on the hypothesis side. Okay, another distinction I'd like to make is an individual-centric versus a group-centric axiom. So claim monotonicity is obviously an individual-centric axiom. I take one person, increase his claim, and make a statement about what should happen to his award. A group-centric axiom would be what I call group order preservation. Let me explain what order preservation is. It's a generalization of equal term of equal. Equal term of equal says if C1 is bigger than C2, I'm sorry, if C1 is equal to C2, X1 should be equal to X2. Order preservation says that if C1 is bigger than C2, X1 should be at least as big as X2. So let's formulate this requirement for groups of people. Take two groups of claimants. Add up the claims of the first group. Add up the claims of the second group. Suppose the first sum is bigger than the second sum. So in total, the first group has a larger claim than the second group. I would say that group order preservation is satisfied if in total, the award to the member of the first group is at least as big as the awards to the second group. So that's a group-centric axiom. I'm looking at groups of people make a statement about what groups are getting. So another distinction that I think is useful is between self-regarding versus other-regarding axiom. So a self-regarding axiom has to do with a change in a personal parameter of a person, and the conclusion is about that person. And actually, we usually start with that. When we vary a parameter, our first inclination is to ask, what should happen to that person? So claim monotonicity says that if agent 1's claim goes up, agent 1's award should not go down. But what about the others? If agent 1 claim goes up, what do you think the other people should get? Would it be okay for agent 2's award to go up? I mean, I don't see any reason. If agent 1 claim goes up, I don't see any reason why agent 2's award should go up. So what I'm going to do is to look at the implication for the other people in the change in agent 1's claim. And I would say that other regarding claim monotonicity is met if whenever somebody's claim goes up, none of the other people's award goes up. And a final distinction, penultimate distinction between monotonicity versus invariance axiom. Very often, when a parameter changes of a problem changes, we have some ideas about the direction in which assignment should change. You know, if population goes up, the new claimants arrive, then each of those people initially present should get at most as much as they were getting. And claim truncation invariance has to do with the outcome not responding to a change in the parameters of the problem. So it has to do with truncating claims at the endowment and saying that that shouldn't make any difference. So if somebody's claim is bigger than the endowment, there's a part of his claim that he will never get anywhere. So tell him, forget about it. So we're going to truncate claims at the endowment, replace every whose claim is bigger than the endowment. We're going to replace it by the endowment, and that should not make any difference as to what people are getting. That claim truncation invariance. So this distinction is between a monotonicity condition and an invariance condition. And finally, that's my final distinction here. A fixed population axiom has to do with, well, models in which the population is fixed, you know, and models, a variable population here is a variable population axiom is one that relates recommendation across populations of different sizes. So I will explain consistency. Later I will return to consistency. I have a formal definition of consistency, but let me explain in words what it means, okay? So imagine a 3-person problem. I have agent 1, 2, and 3. The claim is C1, C2, C3. The endowment is E. Let S be a rule. I apply this rule to the 3-person problem, and I get 3 numbers, x1, x2, and x3. The sum is equal to E. So what I want to do is this. It's a thought experiment. Let's imagine agent 3 leaving the scene with his assignment. He leaves the scene with x3. And what I want to do at this point, he reassess the situation. I start to implement my decision, my choice. And so imagine people coming and picking up their checks. So agent 3 comes in, it picks up his check for x3. And then at this point, I reassess the situation. I still have 2 claimants left. They claim C1 and C2. The amount to divide is E minus x3, right? Because agent 3 has taken x3 with him when he left. That's of course equal to x1 plus x2, because by definition of the rule, the sum of the x is equal to E. And so I have a 2-person problem. The problem C1, C2, E minus x3. So let's apply the rule to that 2-person problem, which is the situation I'm facing at this point. And I would say the rule is consistent if it recommends x1, x2 for agent 1 and 2. So I don't see any reason to change my mind upon partial implementation of the choice I've made. That consistency. So that's a variable population condition, right? Because I'm comparing what I've chosen from the initial 3-person problem to what I'm now choosing for this 2-person reduced problem derived from it. Okay, this was for axiom format, and we talk about axiom content. So I like to make the partition between normative axiom and strategic axiom. I realize I have to accelerate a little bit here. When we talk about bounds, in many situations, we have some ideas about minimum amount that people should get, sometimes about upper bounds that they should get. There's a variety in the context of this model, a variety of bounds that have been proposed. I'm not going to go through the definition. We also can make interpersonal or intergroup comparison of assignment. I talk about auto-preservation for individuals or for groups. Those are examples of those comparisons that we can make. Solidarity is a very important general principle that underlies a number of axioms. Endowment monotonicity, population monotonicity. In model with preferences, you can imagine what happens when somebody's preferences change. If you have a technology, what if the technology changes? Solidarity is has to do with people being together. When nobody is responsible for a change. It's good or bad, we all move together. We all tighten our belt together if something bad happened to us, a hurricane or a pandemic, or if something good happened to us, we all benefit from the expansion of opportunities. That's what solidarity is about. And so many actions actually can be derived from this general solidarity principle. Then there's some invariance requirements called robustness. I talk about claim to aggregation invariance. Composition down is another way of expressing the robustness of a choice to changes or to choice of perspective in evaluating a change. Sometimes we find ourselves in a situation where something happens and we have several ways of evaluating the situation. It's not clear that one is better than the other. And so we would like the rule to give us the same answer, whether we evaluate the situation in this way or that way. And so there are a number of actions that can be seen as expression of this goal of robustness to choices of perspective in evaluating changes. So composition up is kind of the opposite of composition down. When I tell the story about composition down, I imagine an unexpected decrease in the amount to divide. You could have good news, on Monday you make a decision, and on Tuesday when people are coming to pick up their check, you tell them, well, I'm pleased to announce that actually the amount to divide is greater than what we expected. So again, there would be two symmetric ways of evaluating the situation. A composition up is saying that those two perspectives should be equivalent, should give us the same answer. So let me talk about strategic axioms. So in the context of claims problem, actually, we don't have that, people's opportunity to misrepresent are very limited. For, let's say, standard allocation problem in classical economies, on object allocation problem or two-sided matching, the main way in which people are going to manipulate rules is to misrepresent their preferences. So an important property in those contexts is strategy proofness, immunity to lying about your preferences. So we said the rule is strategy proof. It's always best for each person to be honest, to be truthful about his preferences. In the context of the current model here, I have no preferences, right? Certainly explicitly, we don't have preferences. Implicitly, of course, yes, the more money you get, the better. But what it means that we have the same preferences, right? So that's why I don't talk about preferences. So there's no issue about misrepresentation of preferences here. So what people can do, though, they can manipulate their claims, and they can manipulate resources, certainly more generally here. What people can do is transfer claim from one to the other, right? Agent 1 can transfer some of its claims to agent 2. Maybe in total they can get more. Or they can merge their claims. So agent 1 and 2 can merge them into one. Agent 1 transfers this claim to agent 2 and stays home. Agent 2 is the only one who shows up with a claim equal to C1 plus C2. And maybe agent 1 is get more than they would have gotten together if agent 1 had stayed in. And so immunity to manipulation of the agent set is something that's relevant to claims problem. So people could merge their claim, or somebody could split this claim. You can split my claim between my two sons, and then they appear separately as two claimants. And that's quite relevant in the context of the Talmudic example about the marriage contract. Marriage contract is actually a negotiable documents, and you could sell your marriage contract to someone else. And so it was a negotiable asset. And so you may be concerned about, strategic opportunities that come from that. So those are the strategic action. So what I've done here is to provided, general principle according to which you can put some order in this space of axioms. And I think that should be helpful in reading the literature, not just the literature on claims problem, but the literature on any kind of problem, and help you formulate ideas on when you study classical problem. I'm always surprised when I listen to presentation about any axiomatic model that there are obvious axioms that people have not thought about. And whenever you have a self-regarding axiom, very often there's another regarding axiom that goes with it. And people have not thought about that. Whenever you have an individual focus axiom, then often there is a group focus axiom that's an extension to group that idea, and people haven't thought about it. So I think one of my objectives is formulated in writing this book was to help people generate ideas when they study any particular model. So just to continue the discussion of claims problem, and it's not going to be a summary of the literature, but what we had, do we have characterization? And yes, we have had many characterizations: the proportional rule, constantly equal rewards rule, constantly equal losses rule, Talmud rule. Those are the rules that have come up the most frequently in axiomatic work. But other rules have come up too less frequently. So ultimately, you could say, which of the rules should I recommend on the basis of this work? And I'm going to say it's not for me to recommend a rule. I'm going to go to the bankruptcy judge and tell him, if it is a judge that only takes care of divorce, and that person doesn't have to worry about more than two people, right? So that person is going to be interested only in the two-person case. If it's a group of people who know each other, know each other's preferences, and they trust each other. There's no issue of misrepresentation of preferences. And so all the strategic actions are not going to be relevant. And so if people come to you for advice, I'm going to try to elicit from them the sort of concern they have about the situation they're involved in. Okay, that's the first part of my presentation. And the second part, I said I would only spend a few minutes on that. I want to talk about some of my current projects. And so I said that I, just published a book on claims problem, but I'm glad to say that's not the end of the story. There's more questions that could be asked. And so I'm going to briefly talk about 4 projects that I'm involved in. And the first one has to do with this minimal overlap rule that I alluded to. And so I think it's really an interesting rule. And but it had been very completely studied. So that's my first project, is just to do a systematic analysis of the properties of this rule. So what I'm going to do just to define it for you, and I'm not really going to state any results on the rule, but this is a picture that illustrates the definition. But before this picture, let me give you the definition in words. I will imagine, well, I'm going to use the picture a little bit. I imagine the endowment as not some kind of abstract entity, but like a physical continuum. You see this segment here that goes from the E, from this point to this point. Think of it as a one-dimensional physical continuum. And when people are claiming, agent 1 are claiming C1, C2, C3, they're not claiming an abstract part. They're claiming like a specific part of E. It's like, they come with little flags and they say, well, this piece is mine. And, and what they do is claim, think of it as being divided into units. And people claim, if you have a claim of 2, you claim the first unit and the 5th unit. And if your claim is 3, you claim maybe the 2nd, the 3rd, and the 5th. And then what I'm going to do, so everybody is going to claim a specific piece of E. And then what I'm going to do is to look at each part of the endowment and see how many people are claiming it. So a good case is when only one person claims it, right? So you could see here, agent 4 is claiming the entire thing because I guess his claim is equal to the endowment, so he claims everything. And this piece here is claimed only by that person. So there's no conflict over this piece, so let's give it to him. On the other hand, this piece, is claimed by 2 people. So what I'm going to do is to divide equally between them. So that's what I'm going to do. For each amount, for each part of E, I'm going to look at how many people are claiming it. And what I'm going to do is to arrange the claim in such a way as to maximize the number of units claimed by only one person, because that's the best case. There are many ways to arrange claims on top of the endowment, right? And so what I'm going to do is to arrange claims on top of the endowment. I imagine people claiming specific part of E. I'm going to solve a maximization problem. My choice variable is which part of the endowment each person's claiming. What I'm going to do is to arrange claims on top of the endowment so as to maximize the number of units claimed by exactly one person. That maximization problem typically has many solutions. So among those solutions, I'm going to look at those for which the number of units claimed by exactly 2 people is maximized. This second maximization problem, in turn, may have many solutions. So I'm going to look at those parts of E claimed by exactly 3 people. I'm going to look at those arrangement of claims, solving my first 2 maximization problem to maximize those units claimed by exactly 3 people, and so on and so forth. I do that until the end. It turns out that up to inessential relabeling of part of the endowment, I end up with a unique solution. So once I have that solution, I'm going to do what I suggested at the beginning. Every part of the endowment that's claimed by K people are divided K ways. Everyone will get 1 over K of it. And then each person is going to collect the partial payments that he gets from the various units that he claimed. So that defines the rule, and it's called the minimal overlap rule. And actually, given my time constraint, I'm going to explain what it is. It has actually a simple, explicit formula. It's a lexicographic maximization problem, so that it's complicated in general, right? And in fact, proving that this sequential maximization problem delivers a relatively simple rule, you know, that result due to O'Neill is not so trivial. But we have a rule here, and in that first, in this first of the 4 parts I want to talk about, what I want to do is to study the property of this rule. And so what are the properties? And I'm not going to bother you with the result. You know, I've already explained that there are tons of properties that one can formulate for claims problem. And so in this project, you know, identify which properties are satisfied and which are not satisfied. And altogether, should we care about this rule? How well behaved is it? Well, I would say it's very monotonic. You know, this idea of monotonicity, you could change, you could change some disclaim, you could change the endowment, you could change the population. This rule is very monotonic, but it's not so invariant. You know, I formulated a number, I alluded really more than formulated a number of properties of invariance, and this rule is not so invariant. Is it robust to strategic moves that people can take? So I explained that 2 main ways in which we can be strategic. They can transfer claims from one person to the other. They can merge claims. They can split claims. This rule is not well behaved at all. And actually the reason it is not well behaved is that from that viewpoint, only one rule is well behaved, the proportional rule. And in fact, we have a far-reaching theorem about that. And I would say that it is the main reason why the proportional rule we should consider it as a major contender, is that it's very immune to any kind of strategic move that people can take. And by itself, you know, so strategic requirement delivers a uniform rule, the proportional rule. If you want a rule to be immune to claim transfers, you have to be using the proportional rule. If you want a rule to be immune to both merging and splitting of claims, you have to be using the proportional rule. So it's not a surprise that the minimum overlap rule is not so well behaved here. We do have some characterizations, also some generalization of the rule that are kind of interesting. So I will skip that part. So I'll just make complete by, you know, how does it compare to some other rules? Well, I think that's what we want to know ultimately, right? In terms of constellation of properties, I would say it's very similar to the random arrival rule that I mentioned before. I would say it's the same peer group. Okay, so here's a second. How much time do I have left? Michel, can you tell me how much time I have left?
About 5 minutes, William.
5 minutes, okay. The second project is some joint work I started with my student, Patrick Halles, who tragically died a few months ago. And it has to do with a version of consistency that already explained. That's a formal notion of consistency. Let me remind you again, forget about all this notation. Let me remind you of the scenario I talked about. So let's start with 3 people. They claim as C1, C2, C3. The endowment is E. I have a rule S that's going to recommend X1, X2, X3. Let's imagine agent 3 leaving the scene with his assignment. And let's reassess the situation at that point. I have 2 people left. I claim as C1 and C2. The endowment, the amount to divide between them is E minus X3. Let's apply the rule to the 2-person problem. I said the rule is consistent if it recommends X1 and X2. So I've made a decision about my 3-person problem. I start implementing it, and I stop in the middle. I say, well, is that am I doing the right thing? And the answer should be yes, if the rule is consistent. I don't see any reason to change my mind. So some rules are not consistent, but you know, maybe consistency is also a requirement. You know, in that thought experiment, I could imagine, let's say agent 3 leaving, or I could imagine agent 2 leaving. So let's look at agent 1. Agent 1 might be involved into what we call reduced problem. So it could be involved with agent 2. So we'll be looking at the problem C1, C2, E minus X3. Or it could be involved with agent 3 in a problem C1, C3, E minus X2. If the rule is not consistent, it could be that in either one of those 2 problems, agent 1 is not getting X1. But suppose that on average, agent 1 is getting X1. So those are thought experiments anyway, right? So on average, agent one is getting the right thing. So I would say a rule is average consistent if that's always the case. That on average, when I look at those 2% reduced problems that people can be involved in, on average, they actually do get what we had calculated for them at the beginning. So that's the test of average consistency, which is obviously weaker than the test of consistency. And I've written it here. It originated in the literature on coalitional games, but it was adapted to claims problem by Dagan and Volage. And that definition suggests a formulation of what I'm going to call an operator. So the operator is the following. Suppose that I've made a choice in the 2% case of a rule. And why should I start from the 2% case? Because mathematically, it's simpler. Conceptually, it's simpler. We have to deal with groups of people. It's always problematic, right? The 2% case is always a good point of departure. We have more characterization for that case. More rules tend to coincide in the 2% case that they do in general. So it's a really good starting point. And so suppose we have made a choice in the 2% case. And we're wondering, what should we do for more person? Where average consistency provides a basis for an extension to arbitrary population. Take an n% problem, and what you're going to do is to take a pure vector x such that the restriction of that pure vector to any 2% population would, so that for every person, what that person get is the average of what he would get in the associated 2% reduced problem that he could be involved in. So the question is whether such an extension, you could an average extension of the rule exist. And Dagan and Volage have a very general theorem that says as soon as a rule is endowment monotonic, you will have an average consistent extension. Not only that, that extension is going to be unique. So if no matter what you have done, what you have chosen a 2% case, and for instance, sequential priority rule are covered, or the priority don't have to be consistent or transitive. As long as you get endowment monotonicity, which is the case for virtually all rules, then you're going to get a well-defined average consistent extension. So what we wanted to know is in that work with Patrick Harless was what properties of rules are preserved by this operator. So we're defining an operator here, right? The starting point is a 2% rule. And then we associate with it a general rule, a rule that works for 3%, 4%, 5%, so on. So if in the 2% case, we have a rule satisfying, let's say, endowment monotonicity with this average extension be endowment monotonic. If in the 2% case, we have a rule that's like composition down, with the extensions are composition down. We want to know whether properties of the rule we have chosen in the 2% case are going to be preserved by this operator. And so we have some result about that. In fact, Dagan and Volage already had answered the question for the endowment monotonicity. The answer is yes, it is preserved. And we have some examples of properties that are preserved, and we have some other examples of properties that are not preserved. Okay, I think my time is running out. And so I'm going to go very quickly over those other projects. And this next one is some work I'm doing with Juan Moreno-Ternero. It has to do with averaging. So, what do we mean by average? What's the point of averaging? Averaging is a way of compromising. So what I'm going to do is to show you how to average two rules. So this is a picture that I have illustrating in the 2% case what I mean by taking the average of two rules. You see I have two rules, I call them R1 and R2. This is a path of a word of R1 for C. And that more curvy one is a passive word of the second rule for C. So the first rule for this particular budget recommends this point. The second rule recommends this point. And so what I'm going to do is, maybe I'm agent one and I think this is what we should do. And you're agent two, you have a different opinion. So one way to compromise is to pick something in between. And so this is what we would do. And we can do that because of the convex property of the space of the words vector. The space of rules is a convex set. And so what we're going to do is to take the average of two rules. But then we ask, is that the only way to average things? And we propose that one could average in different ways. For instance, given a particular C where C1 is equal to C2, we could ask, given a particular award for agent one, let's call it X1, what would, you could think of a rule as providing answer to the following question. Given X1 and a particular award for agent one, what award for agent two would look right? Or you could ask, given X2 and award for agent two, what award for agent one would look right with it? And finally, you could say, given delta difference between X2 and X1, what value of X1 equivalent with value of X2 would look right for that difference delta. And so if you think of rule providing answer to this kind of question, then it suggests 4 different ways of averaging between rules. You can average along budget line, you can average along lines parallel to 45-degree line, you can average vertically, or you can average horizontally. And so we propose those 4 different ways of compromising between rules, and then we study the properties of those operations. And so we wanted our procedure to be simple, so it's a linear averaging, but we want it to be rich enough, so we make the lambda to depend on C. So that the richness comes from. It's not just a lambda, it's a lambda of C. So what we do is apply those definitions to the proportional rule and the Talmud rule, and then we, this is an illustration of those definitions. And then we want to know, of course, which properties of rule are going to be preserved by those operators. And then we have lists of properties that are preserved and lists of properties that are not preserved. And then we also ask the consistency question, what restriction, what property should this function lambda satisfy for those averaging operation to have consistent extension? So I'm running out of time and my voice is also running out. So I've just mentioned the last topic here without elaborating. It has to do with a subfamily of claims problem in which claims are bounded by the endowment. So in many situations, a claim cannot be bigger than the amount to divide. Suppose we write a joint paper together. I claim to have written 70% of it, and you claim to have written 80% of it. So the sum of the claim is bigger than 100%, right? So I can do that. I can claim to have written up to 100% of the paper, but I cannot claim to have written 150% of the paper, right? So in many situations, your claims are bounded by the endowment. And so the question is, if you limit yourself to a claims problem in which no claim exceeds the endowment, what happens to this theory? And it makes a very big difference. And so what is the implication? So passive awards are restricted, certain properties are trivially satisfied. Claim truncation invariance obviously is going to be trivially satisfied, right? No claim is by definition is bigger than the endowment. So this is a property that disappears. Self-duality, which is a kind of a symmetry property between having too much, having more than to have some of the claim or having less, that property virtually disappears. And so the whole theory would have to be rewritten for that case. So this last project has to do with studying the model in which no claim is bigger than the endowment. So, and let me conclude then by discussing where the literature is going. So I mentioned that the model that I've presented and discussed here is really a very basic model. There, many things have been ignored, but we have a number of studies that have addressed, I think, natural question. And so some people have added the network structure to the model. You know, for example, banks owe each other money, right? Bank number one owes money to bank number 2 owes money to bank number 3 owes money to bank number 1. So this is network structures that has to be taken into account. In some situations, the resource is not infinitely divisible. When, you know, FIFA, Africa wants more teams to be represented in the World Cup, you know, teams are integers, right? So it creates significant differences. You could have add uncertainty to the model. You know, in practice, often claims are not known with certainty. The endowment is a random variable. And there's been some very interesting work done recently on a model with uncertainty. You have to talk about incentive as well. You know, the rules that the feedback effect, you know, the rules are going to be used will impact how much you're going to invest in the business. You know, you're going to think about what if this company goes bankrupt, how much of my money am I going to get back? And so there's a feedback effect that you need to take into account. You have to study this kind of incentives. Those are also general equilibrium effect. Claims could be multidimensional. You know, I've talked about the one-dimensional case, but claims could be in several dimensions. There's a few papers on that, a few recent papers. And then, of course, the theory can be applied. And there's been a bunch of applications recently about taxation, about CO2 emission, how to allocate the right to produce gas with effect on the environment. River sharing is another illustration. And that will be the end of my presentation. If you read only one paper on the subject, you should read O'Neill's paper. O'Neill's paper is kind of a foundation stone of the literature. And there are very few topics, right, in economics where you could say, well, this is a paper where it all started. You could say Nash's 1950 is a paper in which the theory of bargaining, the axiomatic theory of bargaining all started. And O'Neill's paper is where that whole literature on claims problem started. And it's a very rich paper in concept, in technique, and it's a beautiful paper. And I'll close by saying thank you for your attention. And again, thank you for inviting me to this event. I was very honored to be part of it.
Hey, thank you, William, for this very nice talk. So you showed us how understanding historical allocation problems can help in trying to solve contemporary economics problems. And by understanding rules, we find axioms, but then at some moment we maybe have so many axioms that we still lose oversight, and then we have to take a step back and order these axioms. So I think you showed the relevance, the history, and the ongoing work in this field. So I would like to give the floor to someone in the panel who has a question.
So let me add, actually, before people ask questions, if later on you want to, if you have more questions you think about later, please feel free to write to me, send me an email, and I'd be happy to help you.
Can I, yep, okay, thank you. So first of all, thank you very much, Professor Thompson, for your very interesting lecture. You've called the claims problem a pedagogical paradise, but then you were speaking from the point of view of the instructor. And I can testify from the point of view of a student that it's also an educational paradise, how of such a simple model, what you can essentially call the CE problem, such a rich literature has emerged, analytical literature has emerged over time. You have mentioned the canonical seminal paper of O'Neill in '82. I'm also thinking of the Aumann-Maschler characterization in '85. So I think we're talking about, let's say, a 35 to 40 year time span of analytical research on the claims problem, out of which you have prominently emerged, if I may say so, as maybe the biographer of the evolution of ideas on this topic. And so my question is, if you are kind of looking back over the last, over this period, and also look to the future, how do you see this field evolving, moving forward? So of course we have the prominent place of the axiomatic method.
Yeah.
In this field. But also the claims problem has been more recently fruitfully applied in, let's say, experimental economics, empirical economics with applications. We also know at the same time that the axiomatic method is struggling a little bit with these other methods in getting prominent places in top journals in economics and so on. So my question to you is, do you see kind of methodological paradigm shifts when you overview how, let's say, the claims problem is evolving, and what do you expect for the future?
Yeah, well, of course, it's difficult to predict the future, and I don't really want to try. But I certainly see some trends towards more application. Because one of the things I find interesting is how you could say 40 years, there have been almost 40 years since O'Neill's paper, right? That was 82, so now it's 2021. So next year will be 40 years of O'Neill's paper. So maybe to young people, it looks like a long time. But to me, it looks like a relatively short time. And you know, in this relatively short time, we've had quite a complete theory being developed, you know, about claims problem. I was, in fact, you know, look at back 20 years ago, already then, you know, we have very significant result. I mean, Young's result on consistency was proved very quickly, and you know, I think the date was 87, and we've had a number of very important contributions that were quite early. So the literature developed, I think, quite fast. And I think that's because it could rely on the axiomatic method, on the conceptual framework that had been elaborated in some other fields, like say game theory or the theory of cooperative game in particular. And so the theory of claims problem could benefit from this conceptual apparatus, and it allows for relatively quick development of it. So in terms of the future, well, I mentioned at the end, you know, those different trends, and I think this model really is a bare bone model, you know, CE, you know, just n plus one numbers with an inequality. So it's a model you can write down in one line. And obviously, that's at the cost of ignoring a number of real-world phenomena. And that's why I think the literature has developed and will develop further by adding uncertainty, by looking at the case of indivisibility, all those dimensions that I talked about, you know, at the end. So, and I think the literature is bound to develop further in those directions. Now, what would happen, though, is that each of those extension will take multiple form. You know, because if you want to add uncertainty, for, you know, there are many ways in which you can add uncertainty. And what you see already in the literature that people have formulated a different model with uncertainty. And so as the literature enriches itself, it will become a little bit more fragmented, probably. But I think it's a necessary direction it has to go. The experimental testing of of the literature, I think, is also important. What I'd like to see in the context of experimental work is that people tend to focus on rules. You know, when people have tested the literature, what they've done is try to see whether people feel more comfortable or they would prefer the proportional rule as opposed to the constraint equal reward rule as opposed to the time rule. But what I would like to see more work is on testing axioms themselves. You know, how do people feel about resource monotonicity? How do people claim about claim monotonicity? And I'm not aware of any work of that type here. That to me would be more fundamental, because again, I think the axiom as being the starting point, not the rules themselves. So ultimately, you know, we ask people, suppose you have a follow-up conversation with someone, and you know, they've been involved in some experimental study, and they have chosen the proportional rule. let's have this conversation with them and ask, why did you choose this rule? Most people are going to tell you, well, that's it maybe it's because they know that the rules are typically used, but often they will not have a complete view of the properties of this rule. And so what I think the axiomatic program can contribute is educating people in terms of the real reasons why they should be interested in a particular rule. So they have some intuition, but we need to help people express the intuition. And the only way I can think of doing that is making them aware of the properties of the rules. And that's how I would like to see how they feel about the properties. I'd like to see experimental work to develop in that direction.
Okay, thank you.
Thank you. Another question?
Marina?
Should I go or Leon?
Yeah, Marina, go ahead.
Okay. Thanks first for the talk. Also, I was wondering, seems to be a difference between the way mathematics proceeds and the way claims problems and game theory proceeds. So in mathematics, normally the goal is to find a more general language that encompasses different subdisciplines, which reduces axioms. And in game theory and claims problems, what the goal is normally to find transformations of claims into bargaining problems or claims into coalitional games and so on, which proliferates axioms. You get even more and more axioms. So I wonder, first, do you have any views on why it is game theory and claims problems more interesting?
First of all, I'd like to emphasize that when I talk about the axiomatic method, and in this book that I mentioned and that René mentioned, I'm really focusing on the axiomatics of economic design. So I'm fully aware of the fact that the axiomatic method plays a different role in other fields of inquiry, in particular, even within economics. For example, decision theory is very axiomatic, but I think the axiom in decision theory play a different role. The axiom are meant there to be descriptive or plausible description of the way people behave in some simple situation. And from those very simple postulates about behavior, you try to derive, how they would behave in a complex situation. And so for us, when you do axiomatic work in economic design, the axiom do not play that role. We're not to be trying descriptive. We're more likely to want to be normative. And so to express the intuition we have about, so let's go back to the definition I gave of an axiom. I went quickly over it, but I said an axiom is the expression in mathematical form, because we want to do analytical work, right? So an axiom is the expression in mathematical form of some intuition we have about how a rule could behave or could be required to behave in certain situation. So we have, so where does that intuition come from? That intuition comes from, often I say, this is our gut reaction is a good starting point. We find ourselves in a situation we were upset. And so why are we upset? And so we have some intuition about what's fair. And so we need to formalize it, to formulate it, and to express it in a formal way so you can work with it and do analytical work. And so I don't see the role of axiom in mathematics playing that role at all. So I think I don't want to, when I wrote, in writing this book, I really was not attempting to make any statement about the role of axioms in other fields of inquiry, such as certainly not mathematics, and even within economics. Decision theory is another very important branch that is dominated by axiomatic work. And I don't think they have at all that same perspective. There are some papers by, excuse me, some recent paper by Postlethwaite and Gilbora. I need to drink a little bit. So there's an interesting paper you may want to look at by Gilbora, Postlethwaite, and I think there's a third co-author, and it's called What Are Axioms For? Something like that. And they describe how they view the role of axiom in game theory and decision theory. And so the contrast is clear. They have different objectives. I don't know whether I answered your question there, but this being said, when I die, the first thing I'm going to do is to look for Euclid and give him a big hug and thank him.
Other questions?
Leon?
Yeah, thank you for the talk, Professor Thompson. I have a more like practical question, more like also related to PPE. I was wondering, do you think that politicians should make more use of the bargaining model or its insights, that they could make use of that in more practical applications?
So can you rephrase? Actually, before I noticed when you were speaking, I couldn't hear you very well. Could you rephrase your question, please?
Yeah, sure.
Like closer to your microphone.
Yeah, can you hear me now?
Yeah, I can hear you, but I had trouble understanding the question.
Okay. Yeah, I was wondering, what do you think are the insights politicians, for example, should take from the bargaining, from the claims problem and its insights? What should politicians learn from it, or how can they apply it?
Yeah. Well, politician in specific, I don't really know. I mean, this is still, you know, what I presented really is a theory. And so we have to look at the application. And as I said, you know, there are a number of people who have been applying the theory to various types of allocation problems, very practical application problem, like the allocation of CO2, rights to emit CO2 gases. And I talk about river sharing problem. I don't want to give the definition, but those are, this is where the contact is going to be made between our theory and practice. You know, so the model I presented is too simple, really, to allow for direct advice to politicians, but it has to be enriched. It has to be, you have to look at data. You have to look, in practice, for example, it could be that some rules that appear very different in the theory, they might give you a very similar recommendation. So that's relevant to practice, but it's not. But it's not something you would see in the theory. So in each particular application, I think you need to look at the data. But in general, what I feel about, you're talking about talking to political scientists or talking to other groups of people, maybe, the taxation authority, talking about bankruptcy judges and so on. My feeling is that in the long run, my hope is that axiomatic reasoning and the axiomatic method is going to be taught in high school. When I was a student, there was no economics in high school. I grew up in France. There was no such thing as economics in high school. But the field has been taught. Now it's taught much more widely. Even in university, it was very limited. People had very limited education in economics. So we had citizenry that knew very little about basic concepts of economics. But now I think people are much better educated. They understand better what the issues are, but people do not know about the axiomatic method. And what I'm hoping is that the axiomatic reasoning will filter down and eventually will be part of a curriculum in universities and in high school, and so that people can discuss, a solution to problem in terms of properties of rules that they might apply, and that will apply, of course, to political problems.
I fully agree with that.
If I may just add, there's a very extensive axiomatic analysis of voting procedures. And so I don't know how much people in Brussels know about those various rules that they could use, the properties of majority rule versus Borders rule and so on. But the hope is that eventually people will have a good understanding of the properties of voting rules, for example, that they could use to solve all kinds of decision problems, not just economics problems.
I fully agree with that, William. In fact, what I sometimes experience in real life when there is some allocation problem, for example, about a budget, and then usually people suggest a proportional rule. And then when I ask why should we use a proportional rule, then no one has an idea why. And I even have the idea that people do not understand my question why, because as if this is the way we should do it. But then I ask, why should we do it? I think a more broad knowledge about just the axiomatic approach, at least people understand why we should ask the question. And then even it can be that you don't have a good answer, and then so I think that's very important.
Yeah, exactly. Actually, if I may read an anecdote, some years ago, the president of our university decided to meet people from various departments to know what they were working on. And so he had breakfast with the economics department, and he asked everyone in turn, what are you working on? And when it came to my turn, I asked him, well, suppose the firm goes bankrupt. How are you going to divide the asset of the firm? And the president was a lawyer. And he said, well, should they proportionately? And I said, why? He said, because it's fair. And I said, why is it fair? He said, because it's proportional. And so, people tend to, there's this circular reasoning that it's very difficult to get people out of. They see it, they observe it as the observers of the solution being used in practice, and they take it as, that's what we should do. And it's very, very hard for them to think about the atoms of the theory. The atoms of the theory has those principles, those properties of rules, right? So if they were to tell me, okay, I like the proportional rule because, I've observed that other rules are even or actually even something more elementary, the proportional cannot be manipulated by merging of claims. Okay, if you had told me something like that, but he didn't say that, so they don't have a sense of elementary properties that we can bring to the picture to evaluate rules. So that's why we need to educate people in terms of, the significance of actions, the role that action can play in evaluating rules and choosing among them.
People do not need to give the answers, but at least understand the question.
Yeah, exactly. That should be already a major step. Recognizing that, yes, we are choosing the proportional, but why are we doing that really? And of course, in new field, when a class of problem is emerging, then we don't have good answer, right? So we're bound to use rules of thumbs and appeal to tradition and precedent without really having good reasons. But hopefully, as the axiomatic program takes its hold over the subject, then we get a better understanding, better understanding of what could be done and the trade-off between the property that we might require of decision rules.
Akshat still has a question. I don't hear you, Akshat.
Oh, somebody has a question?
Akshat had a question, but
can you hear me now?
Yes, yes.
Yeah.
Okay. Yeah, no, thank you, Rene, and thank you, Professor Thompson. That really was a wonderful homage to Linnaeus. So, I mean, the first part of my question is the one Martin's actually asking in the chat box, right? So the question is, can you think of meta-axioms, that is, axioms over packages of axioms? Obviously, consistency, possibility is one already, but can you think of others? Like, for example, brevity, simplicity, no inclusion of auxiliary technical terms. But the second part of the question, which is actually my question, which is an extension of Martin's question, is that in the philosophy of science, there's this problem called theory selection, right? So there's this idea of like, how is it that you adjudicate between competing scientific theories? And now the axiomatic method, specifically the social choice theory, is being used to study that question. So to generalize Martin's question, what do you think about the prospects of the axiomatic way of reasoning colonizing further disciplines, or rather using the axiomatic method to adjudicate even the problem of theory selection within claims problems itself?
So I don't want to go beyond my narrow field of study, which is really economic design. So I don't know enough about how the axiomatic method fits within philosophy. I'd like to just add maybe to make a small contribution there. When you said, well, are there some meta axioms? Well, in a sense, you know, what I was doing in organizing this field of action was looking for meta axioms. I wanted to see whether it would be not tree in the sense of linears, but whether there would be, and you know, whether there would be a mother of all axioms. Then that clearly didn't happen. But still, you know, there are categories of axioms. That's what I try to identify. And, you know, there are general themes. For example, the theme of solidarity. Solidarity is, I don't think of solidarity as an axiom. Solidarity is the theme that underlies a number of axioms. And consistency actually itself, I don't like to call it an axiom. I like to call it a principle. Because consistency, if you look at literature, I'm also finishing a monograph on consistency. And I think of it as a general principle from which one can derive specific consistency axioms. Because if you go from domain to domain, you know, it always takes a different form. So there's some axioms that have pretty much a unique formulation across domains, like the equal treatment of equal. Equal treatment of equal, you know, two people with the same characteristics should get the same thing. Of course, that same thing could be utility, it could be payoff, it could be welfare, it could be reward. So, you know, what you're distributing could vary, but still, there is something very universal about this idea of equal treatment of equal, treating people with the same characteristic in the same way. But for consistency, it's not the case at all. I mean, consistency, I explained it in the context of claims crime because it's actually the model in which it has the simplest and most transparent expression. But consistency in the conditional form game, for example, has multiple expression, and you know, the model, it comes from the fact that the model itself, you know, is kind of a complex model. But expressing consistency for conditional form games, there are multiple formulations that have been proposed. And so I don't think of consistency as an axiom, it's more like a principle. And so this was one of my goals, you know, in writing this monograph on the axiomatic method, to try to put some order in this field so that we can talk about broad categories of axioms.
I see two more hands in the waiting line claiming your attention. So Fabian.
Yeah, first, thank you very much, Professor Thompson, for this lecture. I also have a more like PPE related question. I also want to ask, like, how could you translate your axiomatic approach or the axiomatic approach into philosophy? Because also, so for all the like a lot of papers that I read about claims problems, they state all these axioms, and a lot of them are very normative axioms. But in the end, I have the feeling they don't then explain when should I apply this or why. Like, just take exemption or exclusion. Very small claims should be regarded or disregarded in any case. Like, and it doesn't give me any why should I do this. Like, it doesn't take the next step to actually explain. Like, is there research done on this, or how do you see the connection between the two fields?
Well, I think the research should be ongoing. You know, you should always be looking for whatever underlines whatever you're doing, but then you pretty much run out of answers, I think. It's a little bit like when you're in a conversation with your child and the child asks you for a reason for something. And you say, well, it's because of that. And the child says, why is that? And you say, well, that's because of that. And the child says, why is that? And pretty soon you are stuck, you know. So I find myself in that same situation. Let's say sometimes you unexpectedly find reasons for a certain intuition you have, but ultimately, I don't think you can go to the bottom of things. That's why I talk about the atom of the theory being certain concepts. And sometimes somebody manages to break an axiom into more elementary pieces, conceptual pieces. Like, for instance, the concept of an NV-free allocation. So with an allocation NV-free, if suppose you have a divisible resource to allocate, and people have different bundle, and people have different preferences over bundles, and you don't want anybody to prefer somebody else's assignment to his own. So that's what we call an NV-free allocation. And so what is the justification for it? What would you say? And so it's hard to go, it's hard to find something more primitive in a way that no NV. And for many years, I've thought this was truly one of the atoms of the theory. I cannot provide more solid foundation just to say that's my intuition about, and I can tell stories, I can tell, I can, in common language, we talk about, would you like to be in this person, would you like to be in his shoes, right? So we imagine this permutation test, that underlies an NV definition. But something more fundamental, and I don't really know. And yet sometimes things come up. So in the context of no NV, it turns out that you can, if you have this property, which is very important for implementation, called masking, usually it's called masking monotonicity. I call it masking invariant because it's really an invariance condition. That together with equal to of equal give you no NV. So you can derive no NV in a certain way. So no NV maybe is not one of the items of the theory. And sometimes when you think about what looks like a fundamental notion, maybe you can think of it differently. And as the field of axiom evolve, sometimes we, those divisions that I'm proposing, I don't think of them as, final. Maybe we'll end up redividing things or reorganizing things, reshuffling things around to in a way that's more transparent and more useful. I don't really know, but ultimately, I think one has to stop somewhere, right? So solidarity, take solidarity. Is that really a fundamental notion? Is there something that prior to solidarity? That you could say, well, solidarity is not really a primitive notion. You could think of it as an implication of something else. What is that something else that would take us to solidarity? And so I think those are very useful questions to ask. Those are the type of questions I was asking in writing this book. But in many cases, I couldn't think of something more primitive. And and where do those notions of fairness come from? For example, you can look at evolutionary theory. You can think about some other discipline that might be helpful in explaining why we feel a particular way about fairness, why we feel a certain way about solidarity. Maybe societies that in which solidarity ideas are prevalent are more stable. Maybe it's society with conflict are going to be resolved better, and that's why they tend to persist, and that's why there could be a variety of reasons why those principles that we think as normative properties of fairness exist and persist. But I don't know. So it could be, maybe should be, that some of the disciplines should be brought in, to provide some foundation for some of those axioms. Yeah.
We are in the final minutes of this meeting. There's one more question, Felix.
Yeah, I'll try to keep it brief then. First of all, thank you, Professor Thompson, for the lecture. You talked a lot about people having intuitions about these sort of claims problems, but not really being able to explain where those intuitions come from. So I would just be curious if, after having worked so intensely on these sort of problems and on especially the axiomatic theory applied to those problems, if your value systems or your intuitions have changed over time in this kind of reflective equilibrium way.
You mean personally, whether my view have evolved?
Yeah.
I'm not so sure. Certainly they've become more precise, because, like everyone, I have my own intuition about certain things, but having to write down things formally, you tend to, your view evolved. Whether they evolved in some fundamental way, I'm not so sure. I mean, I live in a certain society with where there are certain principles of fairness, solidarity that are prevalent, and I'm sure I'm influenced by those ideals. And so I wouldn't say that my views have evolved in some fundamental way, but they certainly have become more precise. And I think this work that I've done in the axiomatic method has been very useful to me, because the axiomatic method, I've become very enamored of it ever since I encountered it. I think the first time I saw the axiomatic method is when reading Nash's paper, 1950, when I was a student. I didn't do too much about it at that time, but pretty quickly after a few years after I graduated, I gravitated in a very natural way towards the axiomatic method because I felt it really provided general answers to question of design. And that's what appealed to me. But then I just practiced it without really thinking that much about it, frankly. And it's only recently that well, not in the last few years, but in the last 20 years, maybe I thought it's important to think about where it comes from and maybe to organize the subject. And that's what I've been attempting to do in this book.
Okay, thank you. Well, thanks, William, for your very interesting talk and very interesting discussion. I also want to thank the participants and specifically the panel members for their interesting questions and discussion. I want to thank also Michelle for arranging this meeting very smoothly. Thank you. Well, now, yes, applause for.
Well, I'd like to also thank all of you for, thank you, René, for inviting me, and thank you all of you for coming to my talk, for your questions, and Michelle also for sending me all those very precise and email helping me with the process. I'm always very nervous about using this technology, but I think it worked very well. So thank you, all of you. And again, if you have questions, let me know, write to me. I've sent this, the current version of my book, I sent it to René. So if you want to take a look, you can ask him or you could write to me. And I wish you the best. I know many of you are still in the process of formulating your research ideas, so my best wishes. And I hope to see you in person sometime soon.
Yes, sure, William. We hope that after the COVID pandemic is over, that we can physically invite you again to Amsterdam.
Yeah, that would be great. I'd love to visit. Yeah.
That's and hopefully some of the students.
We can sacrifice the chicken for good.
Yeah, yeah. Because it's strange. What is strange also with the meetings like this is normally we would now go for some drinks and for some dinner. We would chat on. You would talk with the students.
Yeah, exactly,
there would be a lot of exchange of ideas.
So we're all missing that, and so I mean, this technology has been wonderful. I mean, life have saved our lives. We're extremely privileged, really, that we can continue functioning. But still, it's not the same. It's not the same as one-on-one interaction around a beer, for sure. Yeah.
Yes, I agree. We can do technologically, like with the lectures like this, do a lot, but we cannot replace this social interaction and these drinks. But I hope that we can do that sometime in the near future in Amsterdam.
Very nice.
So I think for this moment, I will close this session. Again, thanks everyone. Well, the PPE Lustrum week continues, so please enjoy that. And well, for the people in the Netherlands, have a good dinner, and for William in US, have a good lunch and the drink. You deserved it.
Okay.
Okay.
Thank you.
Thank you. Bye-bye.
Okay. Bye-bye.
Thank you.